Hi there, welcome back to the channel. Welcome to the start of a YouTube radio restoration project. This one is a Schaub-Lorenz Goldy 40. I've never done one of these before. I've done a Goldy 50 something before. So when I saw this one was available, I bought it and I'm starting the project today. Now, every time I start a project, I think, well, what is the reason for me showing this? How am I going to make it interesting for the viewer? Because to me, it's fun. I enjoy the restoration process. I can do this N times and I'll still enjoy it. But when I'm presenting it in a video series, it can get very, very monotonous. The same thing over and over again. Now, maybe you like watching it. I don't like doing it. I don't like repeating things all the time. So that's one of the reasons why I did the Back to Basics series, where I explain in great detail different parts of the restoration process. So I don't have to show it here. I do it sometimes, but most of the time I refer you to the Back to Basics series. But the other thing is, sometimes I look for what is different in this particular radio, and very often I find it and I'm able to focus on that and try to teach something new from that discovery or experience. Sometimes it finds me, and that's what happened here. I went into this with no plan and no idea how this thing would be different. And yeah, as fate would have it, it decided to punch me in the face with something I'd probably never seen before. And if you want to see what it is, stick around, enjoy the video. But before I carry on, I want to thank the sponsors of the video, PCBWay. You'll find them at PCBWay.com. And they're the people that do all the PC boards that I use on my projects. They've got some amazing prices and great turnaround time. And the ordering process is incredibly easy. If you want to place an order, just go to Instant Quote over here. And there are various ways of doing it. You can put in the sizes and so on. But I just do a quick order PCB over here. And here you can just add the Gerber. What it does is it brings in that Gerber file, and it actually gives you a view of what that Gerber file is going to look like. If you have any doubts that you got the right file, you can then check it from here. I know this is the correct file. Then you tell them whether you want single pieces or panelized. I normally do just single. There's one design per panel. This is the size that it extracts from the Gerbers that I've produced or imported. You tell them the quantity you want. I normally just go for the minimum. I just use 2 layers. Some more characteristics of the actual board. The quickest one is usually the green, and that's what I use. And if you look up here, it tells you 24 hours. Normally I don't need to provide any more information because mine are pretty standard. And then I go here and I choose the transport. As you can see, this they can do nothing about. We unfortunately suffer from exorbitant transportation costs, and it creates a temporary outbox which will be subject to confirmation by the people at PCBWay. They will give you the actual final price and then you confirm your order. Simple as that. In my case, less than a week later, I received my boards, and that is to Portugal. So whatever you need, whether it's the normal PCBs like I use, or if you need any of the other services that they provide, go to PCBWay. I'm sure you find something for your needs. And here's the victim of the next project. It's a Schaub-Lorenz Goldy 40, not one I've done before. It's actually a little bit more recent than the ones I usually do. This one is from 1963-64, so practically my age. And of course, those years were quite near the end of the tube era, and we start seeing some changes in the design and the build of these radios. That dial glass is no longer glass, it's perspex or plastic of some sort. The fonts have changed, the color schemes have changed, so it's all become a lot cleaner, a lot more sort of contemporary looking. The switches are working quite well. We've got long wave, medium wave, short wave, and FM. And then on the left, there's the bass control and bass boost, I think. On the right is the treble control and treble boost. We've got our volume control. It's a single control over here. And on the right-hand side, there's the tuning for the AM, and the dial string seems to be okay. And then for the FM, it's a little bit stuck, so something's wrong. Now the grill cloth, it's not dirty so much as falling apart, which is strange. Now the body, well, it's wood, but it's looking cheaper. And it's got a few dings and dents in there, which I'm sure we can sort out. Quite a bit of fill is going to have to be used here to get that all sorted out nicely. But I think we can do something about that. The back doesn't come with many surprises. We've got the FM dipole over here, external antenna. There's a DIN socket for... this will be tape out and phono in, an external speaker, also a DIN socket. And it looks like we just removed these two guys. And the back should just come out. It's in pretty good shape. Aha. What have we got here? We've got a schematic, but it seems to be stuck. I don't want to force it. It looks a bit precarious here. Let's have a closer look. There's the usual power transformer, output transformer, voltage selector. We've got 220. It's on 220 now. We've also got a 240, which is great. That's actually what I'm going to put it on straight away, because usually that is a problem for me. So I'll put it to 240. It'll be safer. Of course, I'm not sure if anything works, but at least when we test it, we're not risking anything. This seems to be bent. I'm not sure if it's supposed to be like that. We've got a PC board. We've got the preamp and detector tube. Oh, should have seen that first. Somebody removed the plug. But there's the mains wire. It looks original. We've got an EL84 power tube, again as expected. The speaker, not as good as some of the ones I've seen. I mean, this is a small body, so it's probably good enough for this, but it's not one of the massive speakers we sometimes see on these radios. And at this end, we've got probably an EF89 IF amplifier there, ECH91 mixer oscillator tube. It's all looking pretty standard. We've got our tuning condenser. There's a tuning condenser here and an FM block here. And that's the part where the tuning is stuck. It looks like this is stuck here. Let's see. It's moving, but it's very, very tight. It needs some lubrication. Shouldn't be a problem. But it isn't completely stuck, which is a good change. I've just realized that the schematic is held in place with a... Now, I'm going to take this off without damaging it. There we go. Brilliant. Let's see what we've got here. Handle carefully, because this paper is as old as me. We've got everything. We've got everything. That's fantastic. Oh, that's brilliant. Alignment instructions, dial cord layout. Of course, there's the other side as well. There it is, full schematic. Beautiful. PCB layout, component description, alignment instructions at the top right there. I think this is absolutely fantastic, the way they used to do this. Everybody says the same thing, and I'll repeat it. It's a pity they don't do it anymore. So now I'm going to remove this from the cabinet. I'm going to put it on my stand, and we'll look on the underside, see what it is we're actually facing. And the first thing we notice is that there isn't really that much underneath, which is to be expected because this does have a PC board. So obviously you don't have the hundreds of wires and point-to-point component soldering that you'd normally find on the underside of a tube radio chassis. It does, however, make the top a little bit more packed. But the one thing you notice is that it does not have the dreaded paper capacitors, the ones that leak, the ones that you just have to replace on these radios. Most of the capacitors on our film caps, you've still got ceramics, you've still got polyester, but the dreaded paper caps are gone. So mostly we'll just have to replace electrolytics. And now it's crunch time. How do we tackle this beast? When you look at this thing like this, it still looks like a rather complex combination of weird looking components. If you haven't seen this before, it can be pretty intimidating. And I must admit it was for me as well. Now it sort of looks pretty simple. You know, once you've done a few, it becomes pretty much a routine. And I therefore stopped going into as much detail as I used to when I do these restorations. But because a lot of you are still in the beginning stages of the restoration procedure, what I decided to do is create a Back to Basics series. I will link that playlist below. There are probably a dozen videos where I tackle individual tasks one at a time in greater detail, which sort of gives me a bit of a license to skip over some of the detail on here. But I do not want to tackle each restoration as if it was the first. So if it is the first for you, by all means, go through the Back to Basics videos, take them one at a time, apply them to what you're doing, take your time. I mean, this is a hobby. It's supposed to be a hobby. So time should not be an issue here. And it's precisely based on the experience that I've had that I've created a pretty standard series of steps that I take. The first one is power supply. My logic is if the power supply is not working, nothing else is going to work, right? Makes sense. Once I've got the power supply tested, then I go to the next essential step. And that will obviously be the audio, meaning the audio amplifier stage, the preamp, power stage, output transformer, just to make sure that I've got an amplifier at least. And once that is all working, and I can test that quite easily by inserting a signal into the phono input, which is the most direct path for audio through the radio, then I go on to the radio section. Normally I'll start with the AM, because there are normally 3 bands there, shortwave, medium wave, long wave. So if you get that working, you've got 3 in 1. And once that is all sorted out, then I finally go to the FM, which is really my main objective with these radios, because FM on these things sounds absolutely amazing. And once that is done, you sort of go on to the little things. You've got a lot of mechanical stuff that might need looking into. You've got lubrification that needs to be done. And of course, I don't do these things always sequentially. Sometimes along the way, you clean things, and I like to do that so that I get to the end and basically the radio is clean. And a lot of the grunge work has been done along the way, and it hasn't felt like a chore. But before any of that can start, I get the tubes out, keep them safe. Most of them will still work. Need to get the knobs off. Need to get the dial glass off. Now, again, you've got to be careful with this stuff. A lot of the plastics are really brittle, so you don't want to break them. You want to make sure that you do it gently. Make sure that you're not forgetting to unscrew something before you start putting any force on it. So do it slowly. I mean, this thing is old. It's been around for a long time, so treat it with respect. And in some cases, you just can't get it out. So if you don't, work around it. Now, the one thing I found in this radio is that I initially thought the dial glass was perspex or plastic. It isn't. It's actually glass. So again, very gently, very carefully, don't break it. You can remake them, and I've done a couple. I did one on the Brown TS2 and the Brown RC9, I think it was. But it is one hell of a job. Really tough job and quite expensive. But enough of the blabbing. Let me start this with the power supply. Just when I thought this was going to be a normal, straightforward restoration, it gets interesting. Someone has removed parts from this radio, a part that I've never seen removed before. But let's take this one step at a time. I checked the power transformer. I've shown how to do that in my Back to Basics series. It seems to be fine. And now I'm following the leads to make sure that we have continuity according to the schematics. So I've connected the multimeter to the one side of the one wire in the power lead, and it's coming to the back here. Let's see which one it is. It's not that one. The other one comes to here. So there it is. Goes through the fuse. There it is. And then it goes to the various windings in the transformer. The one that goes from the fuse goes to the various windings, and you'll see various resistances. Let's see. Let's get rid of that. Here's the 110 volt or 117, 12 ohms, 127, a little bit more, 220, a bit more, 240, a bit more. Now this then goes to the middle here. That middle there, according to the schematic, goes to the switch. And I looked at the back. I can't find any wire leaving that spot at all. See in the middle there, that is the back of the screw, the selector. And that, if we look at the schematic, goes to one side of the switch. Well, there's been a wire cut off there. And then that side, the other side of the switch, goes to the other mains cable, which is this guy over here. And there's also, and you can just see it, there's a wire that's been cut over here. So between the selector, the middle of the selector of the power, and the wire going back to the other lead of the mains cable. Let's see if I put that on the other lead. Get up the multimeter, and we check to here. There's continuity. So we need to make that connection from that point to the center of that selector of the mains voltage. And there is no switch. So I went looking for it. It shouldn't be difficult, right? I mean, a switch is a big bloody thing. Usually it's a toggle of some sort, and I expected to find it right away. Well, I was wrong. You see, the way the power works here is when you select one of the functions, like that one, which is long wave, medium wave, short wave, FM, it clicks and it holds that down. And when you want to switch it off, there's the off button. You push it and everything springs back, okay? So that goes on, everything springs back, on, back. Now that action should activate some sort of toggle switch, lever switch, some kind of switch that would make the power connect to your transformer. That would effectively switch on the mains to your unit. There is nothing here. I looked everywhere. I looked underneath. I thought maybe this thing is, you know, hidden away somewhere. It should be quite big, but it's nowhere. There's nothing here. And I was driving myself absolutely bonkers. And then I saw something. This over here. This thing over here has got nothing through it. It's a little sleeve, and there's nothing going through it. And I've got a feeling that there was some kind of switch mechanism on a rail across this section of the switching mechanism. Because when you push that down, when you switch it off, or rather when you have it on, that clicks forward. And when you switch it off, it goes back. Forward, stays forward because I'm just switching different bands on, and then off. It goes back, forward, back. So it's that action there, and it seems to have probably provision for some kind of lever to touch on here. You see, that's the part that will be moving forwards and backwards. That seems to have been whatever they had here to activate it as a switch. That is the one that makes it happen. And I can't see anything. I mean, it's gone. Whatever they had here is gone, unless I am being completely stupid. That's possible. And unless you can tell me otherwise, I think someone has stolen the switch from here, probably broke off or something. Now, this isn't a major issue. I mean, I could very simply put a switch on the, on the actual mains cord. So you switch it on outside of the radio, but that's not what I want to do. I want to get this thing working the way it's supposed to. I want to be able to switch on by selecting one of the bands, and I want to be able to switch it off by selecting else. So I need to make that lever activate a switch. And I've come up with an idea, and it's this thing over here. This switch is activated by a lever. See that? It's got quite a long arm. And this one is rated for 250 volts, 10 amps. So this thing is quite hefty, okay? There it is, 10 amps at 250 volts AC. So this thing will work very well for mains. It's actually a normally open, normally closed, but I want to use the normally open so that when I activate it, this thing goes down and makes the connection. Now I've got to figure a way of somehow adapting this to stay on here, and I think I've had an idea. It involves some 3D printing, which is actually something I quite enjoy. Let me show you what I had in mind. I went searching around in my switches and I found a replacement for this one because this thing was really bulky. I found this guy, and at first I thought that it wouldn't be sufficient for the application, current and voltage wise. Then I checked, this thing is 250 volts, 5 amps. And I figured, okay, let's see if we can fit that one in. The first thing I needed to do was design a little support so that this would fit nicely on that rail just below the lever. And this is what I've come up with. So I've got the switch and it's going to sit there closed. Not really what I wanted. I would have preferred it to be in the rest position, but the way that I can get it in there is that it'll be closed, and then when I switch anything on, it'll come on. So this will these two that I've chosen are the normally open positions. Let's see if that's correct. I've got this wire already, so let's just check. Put this in place. We've got continuity like that, and off, on, off. Okay, good. Now this bracket was just done according to the dimensions of the switch. I did quite a few experiments. You try and try again. And the way this is going to work is that, well, I'll show you. You fit that in there, and this thing rests on that aluminium or steel rail. I'm going to stick it with epoxy. I'm going to have to rough the metal a little bit, make sure that it sticks. But in the meantime, let me try and fit this in here. Yeah, that seems to work. So I've got that in there. I'll probably just epoxy that there. I don't want any of the wires to have contacts visible. If for some reason this thing breaks off that shelf, I don't want 240 volts flying around the radio. So I'm going to make sure that that is all sealed up, epoxied up, and safe. So how do we fit this on the radio? Let's have a look. The idea is that this is going to sit somewhere like that. Hang on. Like that. And then when you switch it off, it does that. On, off. Okay. That seems to work. Now what I need to do is I need to rough up that surface, clean it up, rough it up, and I'm going to use some JB Weld to try and fix it in place and see if that holds. Okay, that's been sort of roughed up a bit. I'm going to clean it with some alcohol. I don't want any residue of my fingers or anything else affecting the ability for the JB Weld to take. Okay, JB Weld time. And now we just let it set. I've never been a great fan of working with this material, JB Weld. It works very, very well, but it's messy for me and it takes a bit of while to set. I'm a little impatient with these things, but that's what we have to do. It's working. I've tested it. I've put it on and off. I'm not going to mess around because I want it to set properly. I would have liked to put a screw through there and then let it set, but I don't want to make any more holes on that surface over there because I'm afraid I'll go through and mess up the springs inside. So that's the way it's going to be left for now. While that is setting, I'm going to replace the filter capacitor. Now sometimes I restuff these, especially if they're on top of the chassis and very visible, but this one is sitting here at the back, or rather against the front plate. So in the radio it's at the back, okay? And I'm not going to restuff it. I'm actually going to replace it with a little with two capacitors on this little PC board that I had done, and I think this will fit nicely there. So I'll remove that and put in two 47 microfarad capacitors. This thing is 2 by 50 microfarads, so that should work very well. Let me remove this first. You just remove the wires, make sure you get the right ones. The ground is, or the ground of the capacitors goes to the chassis, this one over here, and then you've got 47, 47. So there's only one wire going to each, so it shouldn't be an issue. Doesn't matter which way around I do it. When I designed this board, I based it on these Nishikons. These are 47 microfarad, 450 volt Nishikons, and they are very, very nice size. So they fit perfectly in here. You don't really need to use Nishikons. You can use cheaper capacitors or simpler capacitors, but these fit nicely. You can see that. If I wanted to put this inside a cap, you can see that, yeah, it fits well. I'll solder this in. And then I've got the ground, that's the ground, and then I've got two solder points for each of the capacitors. C1 has 2, C2 has 2. This is just to accommodate situations where you have various wires going to those capacitor leads. In this case, we've only got one, so it's greatly simplified. And here are the two capacitors looking from the top side. It fits here perfectly. They're pretty small. Let's look on the underside. There we go. The ground is connected to the chassis, the two ground points. The two capacitor connectors are on the upside. There's a bit of a wash or a spacer that I've put in here to make sure that the actual board stays away from the chassis. You don't want this thing shorting. It's pretty solid. I had to be a bit creative and get a bit of metal in there. So I think this is going to last a very long time, and they are accessible, so you can quite easily measure the voltages there as well. All right, I've soldered the switch wires to the respective parts on the back of that voltage selector. So we've got this off at the moment. We can see the levers down. If I switch any of them on, I'm measuring the resistance across the primary of the transformer. That stays the same, that stays the same, and when I switch it off, it cuts it. Right, switch is perfect for now. I've got a little toothpick in there just holding it in place while it sets. It hasn't completely set yet, so I'm a little reluctant to mess with that at the moment. What have we got at the capacitor end? Well, I'm going to set one pin of the multimeter on here. I'm not sure which one this is, 1 or 2, but I know that one of these goes to one winding of the output transformer, that little, well, what is it, a humbucking section of the output transformer. The other one goes to that big resistor that drops the voltage from B1 to B2. So let's have a look at the top where that resistor is and see what we measure. Let's try one side of the resistor. 22 ohms. I think that is the resistance of the internal winding. And this one here, 1.54 K. So we're measuring from, we're measuring B1 plus. So it comes out, goes through the winding, 22 ohms, and then it goes through the resistor and it measures 1.52 K because you've got the other 22 ohms. And then from here, we should be able to measure continuity straight down to the second capacitor. Let's see if that's the case. Connect the meter to the other cap. And that should just be continuity. And indeed it is. Okay, so we've got that section sorted out for now. And this is where I'd be tempted to try to power it on. But I'm a little concerned about something. Why did that power switch fail? Maybe they just had a more valuable radio and they needed to replace it, and they took it from this one, which was less valuable. I don't know. And because I don't know, I'm a little concerned. So what I'm going to do is I'm going to take some time to follow all the lines on the supply, as I normally do. I'm also probably going to replace the selenium rectifier with one of my MOSFET adjustable dropper boards. In other words, I'm just going to take a little bit more time on this because I don't want to blow up on the radio at this stage. So I'm going to ask you to bear with me. I'm going to leave you for now, do all that, come back with some more progress. And in the next video, I'll be sure to, well, switch it on. Whether it blows up or not, I don't think it will. But I will certainly be on more sturdy ground as relates to the possible problems this thing's got. This was unexpected, completely unexpected. I don't think I've ever seen a case where someone's removed a part of the radio when you can't see it on the schematic. Maybe there is something I'm not understanding here. That's always a possibility. If you know better, let me know in the comments. So I do hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, please do so on Patreon and PayPal. Links are in the description below. So once again, thanks for watching. Bye for now. And most of all, stay sane.